So, you've probably played around with AI chatbots, right? They're amazing at talking, but what if they could actually start doing things? Well, get ready because we are on the verge of a massive shift in AI. We're moving from models that just spit out information to autonomous agents that can actually take action on it. Let's break down how. You know that feeling, right? You ask a chatbot for help, it gives you this awesome step-by-step plan, and then you still have to do all the work yourself. This gets us to the really big question that's driving the next wave of AI. What happens when AI can not only tell you how to do something, but can actually go out and do it for you? And the difference here is, well, it's fundamental. On the left, you've got your typical large language models of today. They're pretty passive. You give them some static input and they give you an answer in one shot. Their whole world is just that one conversation. But on the right, that's agentic AI. It's interactive, it's dynamic, it takes multiple steps and learns from feedback, and it can even use external memory to remember things long term. It's a huge shift from a static tool to a dynamic partner. The engine that makes all this possible is something called agentic reasoning. It's a whole new way of thinking that reframes these models as autonomous agents. And the three words you really need to remember here are plan, act, and learn. This isn't just about creating text anymore. It's about using genuine reasoning to interact with the worlds and get things done. All right, so here's the game plan for this explainer. We're going to start with the agent's basic playbook. Then we'll see how it actually learns from experience and even teams up with other AIs. After that, we'll dive into some seriously cool real-world applications and finally talk about the big challenges that are still ahead. Okay, let's dive right in with our first section, the agentic playbook. We're going to break down the core foundational skills that every single one of these AI agents needs to have. Okay, this diagram here, this is basically our roadmap for the next few minutes. It shows the whole system. We're going to start right at the bottom with foundational reasoning. That's the core skill set. Then we'll move up to how it evolves, and finally, how these agents can work together as a team. So, here's the deal. A foundational agent has three crucial skills. First up is planning. You give it a big, messy goal, and its first job is to break that down into small, bite-sized steps. Second, tool use. This is huge. The agent knows it doesn't have all the answers, so it can reach into a virtual toolbox and pull out things like a calculator, a flight booking API, or a code interpreter. And third, search. If it runs into something it doesn't know, it doesn't just give up, it can actively go search the web or a database to find what it needs. And this visual just nails the difference. A traditional LLM, it's kind of a closed box, right? It's prone to having outdated info. But an agentic system, it has a whole toolkit. It can think, realize it needs a specific tool, pick the right one for the job, and actually use it. That ability to use tools is the real game changer here. Okay, so an agent that can plan and use tools is already pretty cool. But here's where it gets really powerful. Its ability to actually get better over time. Let's look at how it learns on the job. And we're not talking about expensive, massive retraining here. This is about learning from every single thing it does. We're back to our roadmap diagram, and we're moving up to that middle layer, self-evolving reasoning. The key concept here is all about creating a feedback loop. See, after an agent finishes a task, it doesn't just move on. It takes a moment to reflect on what worked, what didn't, and how it could do it better next time. This feedback loop really comes down to three key things. First is that self-reflection, where the agent literally critiques its own work. Second is what's called agentic memory. It stores the important lessons from its experiences so it doesn't make the same mistake twice. Put those together and you get continual adaptation, which lets the agent get smarter and smarter with every task it performs. So a single agent that learns on the job? That's amazing. But what happens when you put a bunch of them together on a team? Well, that's when things get really interesting. This is where you see intelligence start to scale up, big time. Or moving from a solo act to a whole collaborative ecosystem. Let's look at our roadmap one last time. We're now at the very top layer, collective multi-agent reasoning. And the idea here is actually pretty intuitive. Instead of having one generalist AI try to do everything, you build a specialized team where each agent has a specific role, all working together to crack a complex problem. And we're talking about a real team with specific jobs. You might have a manager agent that's like the project lead, keeping an eye on the whole thing. Then you have a planner agent to break down the work and create the strategy. A critic agent comes in to evaluate the work and give feedback. And finally, a tester agent makes sure the final solution actually works as intended. It's like an automated, super efficient project team. Okay, theory is great, but what does this actually look like in the real world? Let's shift gears from the how it works to the so what and check out some of the wild applications that are already popping up. For science, this is a total game changer. Imagine an agent that can plow through mountains of research papers, formulate new hypotheses, design experiments, and then analyze the results. It's like putting scientific discovery in fields like chemistry and biology on fast forward. And in robotics, wow, this is the brain that robots have been missing. Agentic reasoning lets a robot understand a complex command, plan all the physical steps it needs to take, and adapt on the fly if something in its environment changes. In healthcare, think about the sheer amount of data for just one patient. An agent can pull together lab results, medical history, doctor's notes, everything, to spot patterns a human doctor might miss. This could be huge for diagnostics and creating truly personalized medicine. And this one's for anyone who's ever had to write a research paper. Imagine telling an AI, find me everything on this complex topic, and it goes out, scours the web, reads everything, and comes back with a fully synthesized report. That's what we're talking about with autonomous research. It's already happening. Now, as incredible as all this sounds, we have to pump the brakes just a little. This technology is still super new, and there are some really big hurdles to clear before we see these agents become a reliable part of our daily lives. Right now, researchers are wrestling with a few key problems. How do we personalize these agents so they work just for you? How do we get them to stay on track for really long, complicated tasks? And the big one, governance. How do we make absolutely sure they're safe, ethical, and reliable when they're out in the real world? And that really brings us to the final and maybe most important thought. We're getting really, really good at teaching AI how to act. The much harder challenge, the one that's going to define the next decade of AI, is how do we teach them to act wisely?